In this presentation, we are going to look at a counting and probability example. So here is the question. A deck of cards contains, you might notice a typo here, this is from an exam paper. There's actually 7 cards and numbered 1, 2, 3, 4, 5, 6, and 7. So just like revise that. An experiment is carried out in which 3 cards are chosen from this deck without replacement. So just draw your attention to that there. Something that's worth underlining. Without replacement. And the result is recorded as an ordered triples. For example, 1, 2, 4, which would be a different result from 2, 4, and 1. So let A be the event that the first card is odd. Let B be the event that the last card is a 7. And what we're asked to do is calculate the number of elements in each of the sets A, B, A intersection B, and A union B. So, or we could sort of verbalize that as A and B and A or B. So, hence calculate the probabilities of the event B, A intersection B, and A union B. Okay. So, first off, let's look at this now again. Okay, so what we have to do here is first off consider a case where there are no restrictions on which card we choose. So I'm going to call this case no restriction. Oops, there we go. No restriction. So in the first instance we can pick from any of the 7 cards. Okay. Then in the second case, we can pick from any of the 6 remaining cards. And finally, any of the 5 remaining cards after that when we pick the third card. So there are 210 ways we can pick out 3 cards from 7 when there is no replacement allowed. Okay, so event A. Well, in the first instance, what we have to remember is that the first card is odd. Okay, so what are the odd numbers here between 1 and 7? 1, 3, 5, and 7. Okay, so essentially what we have here is that we apply the first restriction. We can only choose from 4 of the cards to be in compliance with event A. So once we have picked one of those 4, we can pick any of the remaining 6 for the second card and any of the remaining 5 for the third card. So that's 135. It's 120. Whoops, 120 is the answer to that one. Now, B. So B is the event that the last card is a 7. So what we're going to do is there's a slightly strange way of doing this. What we're going to do is pick the last card first and then go back to the start and just use the remainder. So in this case, we are going to take out the 7 and put it at the end. So there's one way we can pick out the 7. Okay, simple as that. We have 6 cards left. Now we're going to pick out the first one, and then we're going to pick out the second one from the remaining 5. So we have, again, just at the start, we start at the end because the restriction is at the end. So we pick out the 7 there. Then we go back to the start. We have 6 remaining cards. Pick out one of them. Then we have 5 remaining cards and pick out one of them. So there, the number of elements in B is 30. Now, A intersection B. Okay. So, A intersection B is that the last card is a 7 and the first number has to be an odd number. So what we're going to do is we're going to apply the first restriction first, that the last card has to be a 7. Okay. Now, what are the remaining odd numbers? 1, 3, and 5. So we can pick one of these odd numbers to be the first card there. So there are 3 ways we can get an odd number at the start when we're in event A intersection B. 1, 3, or 5. We can't have a 7. But once we have the first card taken care of and the last card taken care of, we can pick any of the 5 remaining cards left. So we would have 15. 3 times 5 times 1. So we have the first three of our answers there. A intersection B, A and B. So what we have to do now is A union B, this one here. And what we're going to do is apply the addition rule. Okay, so the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. And the reason for we subtract the intersection is to stop it getting counted twice. By the way, this is N here, and that's a sort of upturned U. So we have 120 plus 30 minus 15, and the answer there is 135. I accidentally gave that answer there earlier. So the number of elements in A union B is 135. So that is the answer to the first part. What we're asked to do is compute calculate the probabilities of A, B, A intersection B and A union B. So just recall that the total number of ways of selecting cards was, we'll call this N total. N total was 210. Okay, so the probability of A is the number of ways we can select A divided by the total number of ways we can select 3 cards. So here the answer was 120, which is the number of ways we can select, ways we can have A, divided by 210, which is the total number. And that answer there is 57. This is just a bit of calculator work. I'm going to call it 57.12%. You can just, or 14%. That's just a bit of calculator work. You can check your answer yourself. Similarly, probability of B is the number of ways we can have B divided by the total number of ways we can select 3 cards from 7. That's 30 divided by 210, and the answer to that is 14.28%. Again, just a bit of calculator work. Let me underline the answers actually. A union B, A intersection B, number of ways that we can have A and B, all over N total, and that was 15 divided by 210, and that works out to be 7.14%. Okay. And finally, I'm just going to write down the answer to the last one. The probability of A union B is 135 divided by 210, and that is equal to 64.28%. So those are the answers there. So that ends that's the answer to the 4 probabilities we are asked to compute. And that ends our presentation.